Greetings, I'm Yvonne Stapp for Science for the Public, and I welcome you to our Contemporary Science Issues and Innovations program. Today's guests have been called the rock stars of regenerative agriculture. David Montgomery is professor of Earth and Space Sciences at the University of Washington, and Anne Biklé is a biologist and environmental planner. This husband and wife team have produced major books on the relationship between soil vitality and agricultural quality. Their most recent work, What Your Food Ate, explains in fascinating detail how conventional agriculture, through tilling and chemicals, destroys the soil, which in turn diminishes the quality, the nutritional quality of crops, and then ultimately degrades human health. This is essential information for everyone concerned with both our health and the health of our planet. It is a great pleasure to welcome back David Montgomery and Anne Biklé. The information about soil, I think there's some confusion about the difference between soil and dirt. If you would please give us some information on that.
Well, thank you, Yvonne. It's a pleasure to be back and talking with you again. The short answer on the difference between soil and dirt is really kind of a one-word answer, and that's life.
Right.
Soil is not just a pile of dirt. It is so much more than that.
Right.
There's the life forms that are within it. There's the organic matter in addition to the mineral matter. It's really the interface between the world of geology and biology, where a lot of really important action happens, including the initial sort of breakdown of a lot of the things out of rocks that we ultimately need to get into our bodies.
Right. So you've got to have the right kind of rocks to make the right kind of soil to begin with, but then it is alive. Can you tell us just a little bit more about the aliveness bit of the soil?
Sure. For a long time, we thought of soil mostly in terms of physics and chemistry. Mm-hmm. And while that's true that those two disciplines bring a lot to soil, what we failed to realize is that all that chemistry and physics is interacting with some of the tiniest creatures on Earth. So that includes bacteria and fungi, and particularly the communities that congregate around the root system of a plant. And then, of course, there's some larger forms of soil life that, most people have seen or at least aware of. So these might be the things that you run into as you're gardening, like earthworms or beetles, or even as a little kid, I remember those things that I called roly-polies, these miniature armadillo-looking things. Yes. And so those are just a few examples, but it runs the gamut from these small invertebrates like I was just describing, all the way down to single-celled organisms. And who knows, yes, Yvonne, there may even be some life form as yet discovered that some intrepid biologist will, bring to our awareness here in the coming years.
Right. And this is so critical because a lot of what's in soil we can't see, that's vital to it. It is a kind of process of the living and the dead working together to make these ecosystems and so on. Before we get to big agriculture and tilling and so on, can you tell us something about the nutrients there that go to the plants that make a big difference?
Yeah, it runs the gamut from fairly typical things like iron and zinc, mm-hmm, and even phosphorus. In fact, on the point of phosphorus, it's thought there's something called the phosphorus legacy in the soil. And so what that is we've been applying phosphorus for a long time in agricultural settings. And plants it's not always easy for plants, especially in a soil that's not very healthy, to take in all of this phosphorus. But as organic matter increases and as microbial partners start rebounding in their populations, fungi in particular can tap into this phosphorus legacy, to all of this phosphorus sitting around there in the soil, and transport it to the plant. And it's thought that if we improved soil health in agricultural settings, we probably could cut back considerably on the amount of phosphorus fertilizer, because it's kind of like a pantry shelf. It's already sitting there.
Yeah.
But it's just been stowed away and not accessible. So those are sort of run-of-the-mill things. Now, something that's newer that I think we really need to expand our minds here when we talk about a nutrient are compounds that I mentioned, all these microbes around the root system of a plant. They actually are consuming compounds that the plant releases in the soil. These are what we call exudates. Microbes get a hold of those exudates, and in turn, they use that to make other kinds of compounds and molecules, which a good number of which are very beneficial for plant health and survival. Things like growth promoting hormones, signaling compounds that tell a plant about, perhaps a nutrient source somewhere in the soil, or moisture, or the approach of pathogens even. And so in this way, a plant is relying on those underground partners all the time for the nutrients that help it grow, but also for intelligence about what's going on down there, in the soil that we can't see.
Yeah, thank you for that, because that's the stuff we never hear about, that this is a system that's had a lot of practice for centuries and centuries, and nature is really pretty good at this. And then along come human beings, and they bring this great invention, the till, and it goes on from there. Can you please tell us now what happens once you bring in first the tilling, and then we'll move to big ag as well. Just tilling, what does it do to the soil?
It's a fairly disruptive process.
Yeah.
It's kind of like if somebody took the roof off your house and put a giant spoon in and stirred all your stuff up every year. That's essentially what tillage does to the soil. Now, not all tillage is completely destructive, right? There's reasons that farmers have tilled for a long time. It actually gives you a little burst of fertility this year because it stimulates microbial activity that helps the microbes then break down the organic matter in the soil and sort of accelerates nutrient cycling. But if you keep that up often enough for long enough, it can actually deplete the soil organic matter. In tropical regions, that can happen. There's a study in Nature in 1994 that showed that happens in like 5 to 10 years. In temperate regions, it takes more like a century. And if you look back at the history of farming around the world, the places that have had very frequent intensive tillage without other means to help replace that organic matter, it's led to degradation of the soil. Now, so you couple that with, in the last 100 years, the mechanization of tillage, which allowed us to till more faster, and the rise in the use of synthetic nitrogen fertilizers, which also accelerate the breakdown of soil organic matter, but that allow you to maintain high harvests as if you had healthy soil, but in a degraded condition, thereby cementing your dependence on those fertilizers. Those are all things that have happened, fairly recently in the human experience, sort of combining all that, the combination of intense tillage, mechanization, and then growing crops in functional monocultures, just growing 1 or 2 crops in the field, or very simple crop rotations like corn and soybeans, for example, as a simple rotation. Right. But when you look at the kind of practices in farming that could actually help to build soil fertility and enhance the biological relationships that Ann was just talking about, it's kind of the opposite of those things. It would be to minimize the chemical and physical disturbance of the soil, to maintain living plants growing in the soil at all times, sort of keeping cover crops growing in between the cash crops, and growing a diversity of crops, because that would give you a diversity of those exudates that Ann mentioned, which would feed a community of organisms and help support the life in the soil that sort of provides the miners and the truckers, if you will, to get those mineral elements out of the soil particles and into the world of biology.
Right. You've given us a little bit here about what's happening with the nitrogen and so on with the soil as a result with the big tilling and a little reference there to the fertilizers. Can we get into that now in a little more depth about big agriculture? The advertisement for this when it all started was, well, we can feed millions doing it this way, and that involved the tilling and the massive use of chemical fertilizers. And can you give us a little background on that now? What happened and what continues to happen?
Yeah, I mean, one of the things that most people don't really realize about the dawn of what we call modern conventional agriculture is that the reliance on synthetic nitrogen fertilizers to really boost fertility became very attractive in great part because soils in Western Europe and across much of North America were already pretty degraded. And farmers wanted the yields that their grandparents had because, what farmer doesn't want to have more
Sure.
produce to sell? And so we found that by using a lot of these newer techniques, we could keep harvests up. And that's important for trying to feed the world, right? We need calories to feed everybody, and everybody needs enough to eat. And so we spent a lot of the last 100 years, the royal we in terms of society, spent a lot of the last 100 years prioritizing how to think about how to grow more food, how to feed the world. And it came with an unanticipated side effect in terms of further degrading the world's agricultural soils. The most recent UN report on this that I'm aware of projected that by the end of this century, by 2100, if we continue on the path of conventional agriculture that we have today, we'll degrade about a third of the world's ability to grow food by the end of this century. Now, with a population that's growing, that's obviously going in the wrong direction. So the challenge is, how could we basically rethink and reformulate the basic way that we look at agriculture to not only grow enough to feed the world, but to conserve the ability of the soil to keep doing that? And also, as it turns out, as we stress in What Your Food Ate, the new book, what that would do to the healthfulness or the nutritional profile of the food that we grow as well. Because one of the things that's happened as we pursued fairly singularly the idea of growing more food is that we reduce the nutritional content of many of the foods that we actually have been growing with conventional practices. And that's because conventional practices undermine those connections to the soil life that Ann was talking about, that are so important for getting things like vitamins and mineral micronutrients into plants, or helping to stimulate or trigger them to make phytochemicals, which have very beneficial effects in the human diet when they eventually get into our bodies.
Right. Let's go to that directly now, because we go to the grocery store, we get all these products, and they're full of additional stuff to supplement, vitamin supplements, and so on. But we have removed that in the course of big ag. Can you give us a little explanation on that? The nutrition has actually diminished, and we go into this and then we'll talk about the health aspects later on, but that has affected the plants, the insect life, everything around it, and the nutritional value, as well as these plants that are fed to us and to animals?
Yeah, that's kind of the complicated, gnarly problem, Yvonne, right there. In that prioritizing yields and high yields through fertilizers. What we have ended up doing, there's a number of studies out there that anyone can dive into in the book, and also visit our extensive reference list.
That's right. You do have an extensive reference. Thank you. Go ahead.
Yeah. That documents how these conventional practices inadvertently, I don't think anybody was looking to decrease nutrient quality or nutrient profiles in food, but when you undercut these biological relationships, so in other words, when we undercut sort of the innate biology of plants, our crops, what ends up happening is that we don't suffuse them with as many nutrients. And again, I think we really need to think about nutrients writ large here. So it's everything from calcium and magnesium and so on, to phytochemicals, which are compounds that all plants produce. It's just it's as basic to a plant to produce phytochemicals as it is for us to breathe air. And so we want that happening in as robust and normal a fashion as possible. And between fertilizers and then pesticides, all of this just sort of essentially scuttles plant biology. Now, this gets a plant to the harvest finish line, but that's with a lot of inputs and a lot of these compensatory things for biology. And what we're learning more and more is that it is also, leading to plants and animals, for that matter, that land on our dinner plates that have fewer of the nutrients that our bodies actually rely on.
Right, thank you for that. And then, of course, we try to supplement this, right, through this processed food business. And in the business of processed foods has led to a number of other things like genetically modified organisms, something you mentioned, which was, you did a really good job of explaining that, by the way, in the book. We don't see that too often. Hydro farming, these kinds of things. As the sideline there, can you tell us a little bit about this, how all of this has led to decreases in nutrition?
The kind of studies that have looked at things like the decreases in nutrition over the last 80 years or so have reported, various declines in, say, the mineral micronutrient density of foods, or the amount of like zinc or iron in foods. And there's studies that report anywhere from a 5 to 40% declines in that. And so the basic trend, though, has been negative. And that obviously wasn't intentional. It was sort of a side effect of what happened when we focused on breeding crops and growing crops with the singular focus of achieving high yields. But there's things that plants do when they're in very nitrogen-rich environments that affect their uptake of things like mineral micronutrients. And that is, plants have two gene pathways for acquiring things like nitrogen or phosphorus. And so when they get a sort of a free lunch, if you will, of lots of soluble nitrogen poured onto the fields to support their robust growth, they get kind of lazy and they stop producing as much in terms of the exudates that feeds certain kinds of soil life. So they dial back on their recruitment efforts for those microbial partners, fungi in particular in the soil, that are really good at going out and prospecting for mineral micronutrients. So the plants get what they need to grow big, but their supply of micronutrients, things like zinc and iron, gets ramped down because they're no longer supporting their microbial allies in the soil. So the plant's basically spreading a limited amount of iron or zinc through more seeds. It dilutes the amount that actually gets into crops. So it's through disrupting the microbial partnerships that it can lead to the declines in things like mineral micronutrients, and can also disrupt the relationships that plants rely on to stimulate them to make the phytochemicals that are important for not only plant health and defense, but that can serve very beneficial roles in the human body in terms of their antioxidant or anti-inflammatory roles when they get into us.
Thank you for that. And just before we get to the broader health aspect of the effect on health in general, this kind of agriculture has also increased the release of CO2, right, in the atmosphere. Is that correct? Big ag?
Yeah, there's sort of two ways that's worked, and the one that most people recognize is that like a diesel tractor burns diesel, right? So there's a certain amount of fossil fuel use going from the mechanization part of it,
Right.
But there's also a natural gas as a feedstock for making nitrogen fertilizers. So there's a secondary component of fossil fuel use. But the part that most people don't really realize in terms of the history of farming and CO2 in the atmosphere is that there was a study done back in, I believe it was 1978 or 80, so it's been a while now, that looked at this, how plowing up the Great Plains, plowing up Ukraine, plowing up parts of China, degraded soil organic matter to the point where that degraded soil organic matter off-gasses CO2, which goes into the atmosphere. Roughly 1/3 of the CO2 that was added to the atmosphere between the Industrial Revolution and when that study was done came from degrading soil organic matter.
Yes.
Now, nature's made a really powerful way to actually take carbon from the atmosphere and put it in the ground. It's called photosynthesis. It's a very, very powerful process.
Yes.
And so stimulating, if you stimulate plants to put out exudates, they're taking stuff that was captured from the atmosphere, putting it into the soil, that becomes the bodies of microbes. It builds soil organic matter. There's twice as much carbon in the world's soils as there are in the atmosphere. The trick and challenge is how to get more out of the atmosphere using farming practices into the soil, and how to actually keep it there. Not necessarily keep every molecule of carbon in the soil there all the time, because it's a very dynamic system. But to keep that reservoir full, so that on average there's less in the atmosphere.
Yeah, and I think there's sort of, I think, some faulty thinking when it comes to this question of carbon. I think for too long we thought we need to just get carbon out of the atmosphere and then somehow lock it up, put it away somewhere in some kind of a lockbox. And I don't think that's the right way to think about it, because we know that life, all of this soil life, all of these plants, even animals, we need to think about it in terms of cycling. And so the more life we have in the soil, actually, this is a place that we can put carbon to use.
Ah, very good.
And so the problem is, as Dave had just described, is we start burning up organic matter, we start killing off soil life, and that carbon is no longer cycling here, on Earth. It ascends up to the atmosphere and is, then the problems ensue. So I like to think about it as, let's keep carbon in life and let's keep cycling it from life to death to life to death. And this is how we kind of get the carbon cycle back into balance.
Yeah, that's a really good point.
The soil is not going to probably solve the carbon cycle problem. We need both to get carbon into Al Gore's lockbox, a lot of it, and to stop burning it. But in thinking about the role of the soil and what it could play, it's one of the few places we could put that carbon and harvest other benefits from it as well, in terms of enhanced soil fertility, probably a better nutritional profile in certain ways of the foods that we grow. So it's not an either or choice, it's a both and.
Right, and the point was that we have so disrupted this cycle that we have reversed the situation with carbon now that we're releasing it into the atmosphere as a result of the big ag kinds of approaches here. Now, it has also had a big impact on health, and that relationship is not kind of pointed to enough. You do a beautiful job in this book, what your food ate, and would you please tell us some of the effects of the lower nutrition, but also just in general, the kinds of health problems that we see big time today, and that relationship with the farming methods?
Yeah, I think just to kind of set the background here a bit, what used to take us down, Yvonne, and this is, not COVID notwithstanding, but it was infectious diseases. It was, tuberculosis,
polio,
scarlet fever. I mean, all of these things that our grandparents and great-grandparents faced. As we got infectious diseases under control, from about the mid 20th century forward, this has been a, kind of a work in progress. What folks were realizing is that another kind of disease, other kinds of health conditions were taking us down. And these are the so-called chronic diseases. And so these are things that sort of, across the board, they have some kind of perturbed or disordered immune response to sort of our diet and our modern lifestyle. So this is stuff like asthma or type 2 diabetes, or, there's a long list of these disorders linked to immune function. And what we now know about the way that the human immune system works is that there's a couple of ways in which the human diet affects these things. One is that we go into in the book is comes in this broad area that we call a fat balance. And so this has to do with the relative amount of two kinds of fats, an omega-6 fat and an omega-3 fat. And you need one of those, omega-6s, these will initiate and activate an immune response, whether the body's facing COVID or healing a wound or something like that. But then once that problem is taken care of, you need another kind of fat to turn inflammation off. And this is a newer discovery and realization for immunologists, because they used to think, oh, well, it's probably maybe, just sort of like this thing that just kind of runs out. And that's not the case at all when it comes to the way our immune system works. The go-to process is inflammation. And so once that starts, problem is solved, it needs to turn off really fast. And this is where that other fat, an omega-3 fat, comes into play. It's the building block for shutting down inflammation. And basically what's been happening is that the human diet, the proportion of those two fats in the human diet has been changing, and we've been consuming far more omega-6 fats than omega-3 fats. And so it stands to reason from that we've kind of turned our inflammatory process on and been unable to turn it off when it needs to be turned off. And so when you get inflammation running amok, this is where the autoimmune conditions come into play. And so this is sort of the rubber meets the road on all this. When we're eating animal products in our diet, those animals have been eating a diet really rich in grains. In other words, the seeds of plants, instead of the leafy and living parts of the plants. All those seeds are very rich in omega-6 fats. All the living parts of the plants, because omega-3s are part of photosynthesis, that's how we get omega-3s into the animal foods. But shifting them onto a grain-rich diet, it shorts them and us on omega-3 fats, and you get inflammation just running amok. And another really important part of helping to quell inflammation and normalizing our immune response are these phytochemicals. These are all of the plant-made compounds that our cells in our tissues are able to pick up on signaling and information that these phytochemicals bring into our body, and that helps normalize our immune response as well. And this is important throughout life, from infancy into middle and old age. And particularly as the American population is aging, it's really important to pay attention to how do we keep a damper on inappropriate inflammation so we can kind of curb all these chronic diseases.
Right. I hope your readers will pay close attention to your concentration on the processed foods and on this decreased nutrition in the big ag approach to producing food and then processed food as part of that, because so many diseases seem to derive from this, and our approach is put a Band-Aid on it, a medication for diabetes to a medication for heart disease, and on and on. And meanwhile, many of these problems are occurring in younger people today as well. It's a very, very good material in your book on that. And then I'd like to, in our last few minutes, to go into the regenerative farming aspect. What is it, and how long does it take to revive the soil? Those are the big questions in our last few minutes.
Yeah, well, there's still arguments over just what the word regenerative means in agriculture. So we'll be sort of good academics here and just try to define what we mean as we start talking about it. And the way I think we look at the regenerative agriculture is agriculture that can rebuild and maintain the fertility and health of the soil as a consequence of intensive farming. So it's basically thinking about farming practices that are intended to build the health of the soil as the foundation for then building, for healthy harvests and for healthy food. Now, what we found that really kind of boils down to is a few simple things that turned out to be fairly different than what we conceive of as conventional agriculture today. So if you look at sort of the elements of what a regenerative farming operation would be doing, they'd be minimizing the chemical and physical disturbance of the soil. So that means that, either going to no-till and not tilling, or to minimal till. If you're an organic farmer and you're using tillage to control weeds, it would be to use it at the bare minimum possible, but then also have a supplemental way to rebuild the organic matter that you're losing by doing that tillage. So minimizing the chemical and physical disturbance of the soil, maximizing the amount of organic matter being grown on the soil, or the coverage of living plants. So that's growing cover crops in between your cash crops. And that's one way to get organic matter into the soil as green manure. And then the third step would be to grow a diversity of plants, to have a community of life both above and below ground with lots of potential partners to interact with for different purposes. Another element of many regenerative farms is reintegrating animal husbandry with cropping operations, getting livestock to manure the fields. And what Ann was talking about with the omega-3 and 6 fats deal, if you have livestock that's grazing on crop stubble or grazing in healthy pastures, they're going to be more rich with omega-3s at the human health benefit as well. So basically, if you think about regenerative agriculture, it's thinking about practices that leave the soil better off as a consequence of farming practices in terms of soil health. Now, how long does it take to restore health to land? Well, it depends sort of how aggressively one goes about it and the length and how much one dives into regenerative practices. But we've seen farms where there's sort of big changes. You can start to see changes within a couple years.
Oh, that's great.
Which is actually fairly fast. And there's many farmers and many farms that we visited where farmers adopted these practices, 5, 10, 20 years ago and have seen big changes on their farms. We did a bit of an experiment with 10 paired farms across the country, looking at the health of the soil on a regenerative farm and a neighboring conventional farm. And the regenerative farms had been farming with that full sequence of minimal disturbance, cover crops, and diversity for between 5 and 10 years, which to a geologist like myself is not much time.
Right.
To an individual farmer, 5 years could be a long time. But so you
Right.
start to see change within a couple years.
Yes.
And in that 5 to 10 year window, these regenerative farmers had doubled the topsoil organic matter content and tripled their soil health scores on theirs. So there's fairly rapid changes at a societal level, which, if they were implemented broadly, could radically transform agriculture for the better. And the best part of that I have left out so far is that, once these farmers restored the health and fertility of their land, they were harvesting as much as their conventional neighbors.
Bravo.
There was no yield loss. So it's not a question about feeding the world versus nourishing the world. We can do both.
Yes.
But these farms were also more profitable than the conventional farms, which is one of the big reasons why regenerative practices are catching on in farming communities, because farmers are stretched pretty tight these days.
Yes,
and
they
this
are.
gives an option for cutting down costs while maintaining income.
Yeah, and I think just, to put it really simply, Yvonne, if it's good for the land, it's good for us too.
Well, and for nature, you restore nature as in the process of this. I am terribly sorry. We are out of time, and this is really interesting and very valuable for the public. I urge people to read this book. It's very accessible, and it is very educational. It should be out there in school libraries too. But people, thank you very, very much for all this wonderful information, and keep writing by all means. Thank you.
All right. Thank you, Yvonne.
Thank you. Pleasure to talk to you again.